This is the vernier surface temperature sensor. It's used to measure temperature. It's used in our physiology manual, the engineering manual uses it, but it can be used in a lot of different places where you want to measure temperature. It's actually the same basic device as our stainless steel temperature probe, in that it is a thermistor and whose resistance changes as a function of temperature. The main difference is it's not inside a stainless steel protective sheath that the other one has. And so it gives you some options. One is that it actually responds much quicker to temperature changes. So experiments like for physiology, you can look at the warming response of the nasal cavity with this. So that you might need that really rapid change. It's flexible so that you can tape it to your skin for that. Now the other issue with that is because it doesn't have the stainless steel sheath on it, that it's more susceptible to damage. So you need to be a little careful with it. It's really designed for air and water only. We don't advise that you put it into chemical solutions, acids or whatnot. So we're going to collect a little data with this, and I'm going to do this. I'm going to attach this into a straw and just tape it onto there, and then I'm actually going to just breathe through the straw, and we'll watch what happens as I breathe in and breathe out, and you can see that rapid change in temperature as we do that. So for the experiment that I would like to do, I need to be able to bend this, the tip, and that's one of the real advantages of this one. It allows me to bend the wires, and then what I will do is attach this to a straw. So I'm just going to ease that down into the straw, and then I'll put a piece of tape just to hold that in place for my experiment. And now I'm ready to collect data. So I'm going to plug it into the analog port. It's an analog sensor. So when it comes up here, we have our default setting here. So we have temperature there in channel 1. And if we look up to the upper right corner, we see our default collection parameters, time-based, 2 samples per second, 180 seconds. And what you're seeing there, and it turns out to be the same setting that you might find with really any temperature device that we have. So the stainless steel temperature probe also defaults to these same settings. Now for the experiment that I want to do, I'm just going to shorten up my duration to 30 seconds. That'll give me enough time. I'll leave my sample rate the same. So I'm just going to come under there, and we'll go here and tap where it says 180, do 30 seconds, done, okay. And now we're ready to collect data. At this point, I'm going to press the collect button, and then I will just breathe through the straw and we can watch the temperature. And now our data collection is complete, and when the collection is complete, it auto scales the graph, so it makes it as large as possible given the data we've collected. So now we can take a look at this and maybe do a little analysis. One of the things we might be interested in is what's the maximum change in temperature from the highest point to the lowest point. So we could do that by just looking at the statistics. And so I'll go to Analyze and tap on Statistics and check the box next to that. And then we see here the minimum and the maximum temperature. So the minimum 23.3 degrees Celsius and the maximum 33.4. So it looks like we have about a 10-degree delta between the highest temperature and the lowest temperature on the graph there. So the lowest temperature would be just the outside air coming in, and the higher temperature is my exhalation, and we're looking at that temperature. So we've seen the flexibility of the vernier surface temperature sensor as its main attribute, so we do need to use some care with it because of the flexible wires, but being able to use it in ways that you can't use other sensors is really key there. And if you'd like to check out other uses for this, you can check out our website, and you can see what other people have done with this sensor.